Hi, this is Professor Ornsby, and yesterday we had another professor's readiness check, and I just want to say that this one is fairly interesting because it really applies across so many avenues of algebra, even trig, but especially calculus and its pattern recognition. And I really have often said that patterns are the underlying foundation of most of math, if not all of math. And that is what I see when I start teaching calculus every semester, is that students are not really struggling with the calculus, they're struggling with a lot of times the algebra and trig foundations that underlie the solution to the calculus problem. So we're going to look at one of those today. I kind of already gave it away. So the idea is that you're looking for a pattern. And so yesterday I presented this to you guys to solve. And if you were able to do it and factor both of them, congratulations. If you did really well on the first one, but maybe you struggled with the second one, you didn't quite see the pattern, you're not alone. And so we're going to take a look at that. But in case you didn't see it, I want to give you the opportunity. So pause the video and give it a shot, and then come back and we'll solve it together. All right, so let's solve this together. Let's solve the first one and see if we can't find the patterns here. Well, what you're looking for when you're factoring is you're going to simplify this expression by factoring, and these have a common factor of 3, and then these terms, I'll do a different color, they have a common factor of x. So we're going to factor out a 3x. So when we factor out 3x, 6 divided by 3 is 2x squared divided by x is x, and 9x divided by 3x is simply 3. So this right here is what we took out of each of these expressions, or each of these terms in this expression. And our final answer is the following. So this is our final answer. Now let's take that idea, and what we often do in calculus is we take a simpler problem and we take what we learned from that simpler problem, and we extend it or extrapolate it into the more complex problem. So let's take a look at this one. Well, this one is somewhat similar. There's a 3x squared here, and there's a 3x on the outside, but we have an extra factor of x plus 1 as well. And so we're going to factor out a 3 common to those two, the 3 and the 6, and then we're going to factor out an x common to those. Let me use a different color since I already used my green. So we have the x's, so we're going to factor out a common x there, one of them. And then on this term, this one's a little tricky because you've got 1/2 and you have -1/2. So take the lesser, and I'll show you why in a minute. So we're going to factor out a common 3, a common x, and a common x plus 1 to the -1/2. All right, so let's do that. So we factor out a 3, and in the first term we're left with just 1, and we don't need to write 1, it's understood. Then we're going to factor out an x, and so we're left with just a 1 there. And then we're going to factor out, I'm going to go ahead and just do the first term. So that's the 3x, the first factor there, 3x. Now let's go look at, so what we have is a 1 here. All right, then let's look at this right here, 6x squared. We factor out 3x, and we're going to have 2 left, 6 divided by 3, and x squared divided by x. Very similar to what we did above. 3x times 2x right here is 6x squared. All right, now we're going to factor out the green one. So we're going to factor this one out. And so we're going to factor out x plus 1 to the 1/2. All right, well, that is exactly what we have. Sorry, we're going to do -1/2. So when we factor out x plus 1 to the -1/2, you're going to have to add exponents. So what do I need to add to -1/2 to get 1/2? So you're going to have to add 1. So we're going to have x plus 1 to the first. And then we factored that out, so there's just a 1 left. All right, so we have 3x, x plus 1 to the negative 1/2, and then we have x plus 1 plus 2x, and you always want to fully simplify. And so we get 3x times the quantity x plus 1 times the quantity 3x plus 1. But the key is that the pattern that we had up here, we factored out that very same thing actually. We factored out a 3x from these two terms, and then we looked at the x plus 1 and we factored that out. All right, well, that was all based on patterns. And so why does that matter? Well, pattern recognition, like I said earlier, is something that we use a lot in calculus, and it shows up in algebra, and the underlying pattern necessarily hasn't changed, but the application has changed. It's a little more complex. But the same question is being posed. What do these terms have in common? So pattern recognition leads us to some algebra, and all of that is really driven from a calculus problem. But this is all foundational to the calculus problem. So how do you know if you are struggling in any of these foundational skills that are necessary for calculus? Well, I created a free calculus readiness assessment, and you can find it at this QR code by scanning the QR code, or you can find it at calculusready.com, and it will help you identify your strengths and your hidden learning gaps. You get a personalized readiness score and feedback from me. So good luck in class, and I'll see you next time.